Hello, Internet. Hello, LinkedIn Live. Hello, folks that are watching this on other platforms, including the RSS feed, as we will make this into a podcast. I'm Frank Lavinia, and this is the very first episode of Impact Quantum. Quantum computing is about to radically change how we live and work. So let's roll the intro. All right, with me to my, I think it's left on the screen here, is my co-host from Data Driven, Andy Lander. How's it going, Andy?
Hey, Frank, it's going awesome. How are you?
I'm doing well. I've got the fever.
Do you?
It's not COVID. It's not Corona. It's quantum fever. That's what I got. So Andy and I have another podcast, datadriven.tv. Where we explore the emerging fields of data science, machine learning, and artificial intelligence. And you're probably wondering, what the heck are you data science-y, data engineer guys doing here talking about quantum computing?
For reals.
Let me tell you a story. In November of 2019, this is back when people would actually travel places and congregate in large groups without thinking twice. This is before the words Wuhan meat market were commonplace, before when Corona was just a beer. I attended a conference called MLabs, or Machine Learning and Data Science Summit. It's an internal-only kind of conference for Microsoft employees, thrown by Microsoft Research, where they kind of come out of the lab and they talk to us about kind of what's around the pike. And this is the conference that I went to in 2016, where I had my aha moment, or about getting into this field. Right, I was into data visualization and Power BI and kind of munging data with Excel, but the engineer in me was not satisfied. Then I discovered machine learning and artificial intelligence and where that was headed. And when I came back from that conference, completely switched on about this is the future. This is coming. It's here. It's on its way. Most people thought I was crazy. I mean, even I had my doubts about it. So through a number of coincidences, it took me or other reasons, it took me about 4.5 years or 3.5 years to get back there. And the first day came and went. I didn't have that aha moment. So I'm like, well, maybe that's just like a once or twice in a lifetime type aha moment. It happens. Doesn't happen.
Sure.
And then on the second day, it was a hardware presentation. Now, I can't talk about everything I saw, but that's when quantum computing was explained to me and why it is the next big thing. And I knew I was on the right track, because when I came back, I started telling other people that quantum is coming, quantum. I sounded again like a ranting lunatic. And that kind of told me that maybe I'm onto something, because the next wave always looks crazy before it happens.
Yeah.
So with that in mind, I started studying quantum type computing articles and whatnot. And I even installed Q# that night in the hotel. Then I opened up my my Visual Studio and was like, okay, now what?
Yeah.
And once again, trying to keep a growth mindset here. When I first read a book on statistics, my first reaction was, what did I get myself into?
Right. But that's not uncommon, Frank. A lot of people come into this and, when you're starting out, who knows everything you're going to learn and everything you're going to need to learn.
Exactly right. And I think that there's going to be a lot of people that are going to be in the similar boat. And on our main show, we kind of discussed this, is that it's hard for people to think back. I mean, it's hard for people to think back honestly about what life was like before COVID, getting into elevators. Like, whoa, other people on it at the same time. Things like that. But it's hard to go back even further to think that there was a time when only PhDs did data science, right? And there was a whole thing about, well, you have to go back to school. Like when I asked folks for advice on what to do at that summit, actually in 2016, I know that one guy's like, just go back to school and get a PhD in statistics. And this is before data science programs existed at universities. So this was really, we forget how quickly this has moved. I mean, now everybody and their cousin has a data science course. And I don't mean that disparagingly. I just mean there's just the Germans have a phrase. It's been a while since I spoke German on a daily basis, but it was Qual der Wahl, something like that. It was like the agony of choices. And we kind of have that now, which 4 years ago we didn't. But around 3 years or so ago, a guy named Siraj Raval, and I'll just drop his name, I won't say anything else, opinion-wise, had the ability not so much to conduct unique and custom research on his own, but he did have the gift, his true talent, was explaining these complicated data science, machine learning, and artificial intelligence concepts in simple ways.
Yeah.
And it is a rare gift that if you can understand something, you can explain it. Now, Richard Feynman, a noted physicist, he says if you can't explain it, you don't understand it. Or you can't explain it simply, you don't understand it. Something like that. I totally butchered that.
No, you got it. Yeah.
So the key here and the goal for this show is going to be just that, like the ability to explain this in a clear and simple way that engineers can understand. Maybe not your grandma, unless your grandma happens to be a particle physicist. It can happen. I had a great aunt who was sister to my grandmother who was an engineer, which back when in the 40s and 50s was a woman engineer was quite an accomplishment in the military, no less, too. And it was not Grace Hopper, no, but though that would have been cool. In any case, the key here is that we want to explain this in ways that software engineers and data engineers would understand. And that's our goal for this show. And now, the best way to set up a learning scenario, which in the last 4 years or so, I have made learning a priority in my life, right? Yep. I have the numbers to prove that too. 66 certifications since December 2016. So I don't say that to show off. I just show that to say, like, I got, it's just become who I am now. It's become a habit.
Yeah.
I don't know where I was going with that, but the best way to set up the learning here is the notion for learning is to set up a reason why, right? If you want to learn something, you're going to be far more motivated and far more likely to capture that information and retain that information. And
agree.
So let's start there. Why? Why should you learn quantum computing? Why is this? Like, the data science world is rocking, right? Like, AI is rocking. Yeah, it is rocking. However, winter may be coming, right, to continue that Game of Thrones theme. And I'm going to try to share my screen. And if you're listening to just the audio, don't worry, I will explain this in a way that makes sense. Hopefully. Let's see if I get that screen up. All right. So what you're seeing here is an article. It's from VentureBeat that basically researchers at MIT warn that deep learning is approaching computational limits. Yeah. Now, what does that mean? Well, I thought the cloud had infinite scalability. Well, it kind of does, but there is a practical upper limit that we are starting to bump up against. And this is kind of the thing that got my attention. So this article is from July, but I heard this in late last year, kind of about that. This is becoming a problem. And let me explain why this is a problem. Because let's take GPT-3, for example. So GPT-3 is a natural language processing model. It took about 175 billion parameters in, right? So that was just the input level, right, in terms of what it could do. It took a certain amount of time to train that, and it cost somewhere between $5 and $12 million, depending on who's answering the question, right? Yeah. GPT-2 only had 1.5 billion parameters, right? So
Yeah.
that's an order of magnitude greater, right? 175 from 1.5. If there's ever going to be a GPT-4, we're now looking at we're now looking at. I totally lost my train of thought. Okay. Thank you for handling the comments, Andy.
Yeah, that's what I'm listening.
We are streaming this live. I actually, I might edit this part out of the RSS feed, but I announced the show on Rupesh's show on Wednesday. He has an Instagram live thing going on, so I announced the show. So that gave me a little bit of extra leverage to do this on time today. But the short of it is that we are hitting these limits. So you can imagine what a GPT-4 would have trillions of parameters. And I don't know if this is going to be, what's the cost going to be? Is it going to be an exponential rise? But at some point, we are going to run out of compute. And certainly doing this at scale, we are going to run out. What this means is somewhat concerning, kind of 3 to 5 years out, is that the innovation in research is going to stop. Right?
Yeah.
And once the innovation in research stops, the new products that come out, that get venture funding, that ultimately get bought by some of the big tech firms, is going to start slowing down. That's
what we call winter, right?
Right. That's AI winter. And if you think this is implausible, I urge you to take a look at history, because this has happened before, and we are at the early stage of this potentially happening again. Predicting the future is hard, by the way, in case you didn't know. But if you look at the advancements that were made in artificial intelligence Alan Turing came up with the notion of the Turing test, kind of defined kind of the core principles of what we call the field of artificial intelligence today. This is a 70-year-old, we're in the 7th decade of AI, right? Now, to read some of the breathless press releases from various companies, you would think that AI started about 2009, 2010. Not true. But at every stage that there's been advancements in AI, and I'm talking going back to the 60s, and even in the 80s, when the concept of neural networks were really pioneered and kind of used, at every time there was a burst of innovation. And at every time, the innovation outpaced compute's ability to keep up.
Yeah.
So then that led to AI winters. So including the worst AI winter so far has been from the mid-'80s till about 10, maybe 12 years ago. Now, that doesn't mean that research doesn't happen in that field in the meantime. I actually took my first course in artificial intelligence in 1994. No, it was the second semester. So it was 1995 or 1994.
Wow.
And
back when years began with a 1.
Right? Crazy. There are people that are probably watching this that weren't even live then. And my professor at the time, noted researcher in the field, ex-IBM, doctorate, distinguished engineer, smart guy. But he was like, oh, this is going to be the next paradigm. This is going to be it. And basically it was Prolog. It was a Prolog programming course.
Yeah.
And the final, I kept waiting for okay, where's the AI coming from? Where's the AI coming from? And that aha moment never came. It was just basically kind of a hybrid of inference and recursion. It was like, that's it. And a lot of these expert systems that he was an expert in expert systems, so that's very meta right there, were essentially, if you kind of peel the covers back, they were essentially just a ton of if-then statements.
Yeah.
Again, where's the AI in that, right?
Right.
So that really set me up to not be a non-believer. So much to the point when I saw some of the early work, before they were cognitive services, this was they were just still in the research lab. They had a DC Tech Fair, which is essentially researchers come out to DC at the Microsoft office to kind of show off what they're working on. And a number of it was computer vision and artificial intelligence. And I saw this thing where he uploaded a picture to this program, and it was a picture of a cat. It was a picture of a cat, and he uploaded it, and the description came back saying, "Hey, this is a picture of a cat." And I'm like, I looked at that, and I was like, my first part of it was like, yeah, that's cool. Then my cynic kind of came out, and I was like, yeah, but it's probably some kind of weird inference recursion thing going on. So I kind of walked away and continued filming the rest of it. I actually filmed the event. You can check out the video on YouTube, which we will link in the show notes. So that left me very skeptical of what the state of the art was. It wasn't until I saw kind of what the real state of the art was at a follow-on event a year later, the aha moment that I had, the Blues Brothers moment, as we've often referred to in the datadriven.tv show. So that takes us to today, 2020 or 2019, is when I was there. I actually recorded a data point right in front of the building. I made note to record outside because of various reasons. And that got my attention. And as luck would have it, fate, the universe, or whatever, I started getting back into it a few weeks ago when this sort of article started popping up that, you know, we are dangerously close to an AI winter because of just the nature of how dense we can pack transistors. Moore's law may be coming to an end.
Wow.
And if it doesn't come to an end, it's definitely not going to be the 18-month cycle or less than 18-month cycle. It's going to start taking longer. Now, we take that for granted. Sorry, go ahead, Andy.
No, I was just agreeing with you. Yeah.
We take it for granted. I hear my phone buzzing, but I don't know where it is. But your phone, here it is. Your phone has more compute power than NASA had to send during the Apollo 11 program. Which, let that sink in, right? You have more power than that. You have more network connectivity, right? We are spoiled. It has been, Moore's law has been in existence for decades as well. We don't know what it's like to not have Moore's law. That is going to cause some serious problems for just computation in general, right? Not just AI.
Right.
So in this, enter quantum. And this is why quantum is coming, so to speak. Every major cloud provider has or is about to have a quantum service. So clearly there's something going on, right? There's a lot of money being thrown at this. There's a lot of research being done. I am not alone in my belief that quantum is coming. It's the question of when is it coming and how will it manifest itself.
Right.
So if you go ahead, Andy.
No, I'll agree with you again. And I think what you said, it's easy to gloss over what you just said about how used to Moore's law we are. And we'll put a link into, you could certainly search this up, search this on Wikipedia, but it's the idea that it's every 18 months that the amount of transistors we can pack into an integrated circuit doubles.
Right.
So, it's not that, I don't know a better way to describe it. I mean, I could actually use, examples that we've all experienced from the recent pandemic. We're recording this on August 14th of 2020, and we're dealing with the repercussions of a global pandemic, or a deadly global pandemic. And there's a lot of things now that we didn't know that we didn't know before this hit. And it's that kind of thing. Moore's law, it falls into that category of we don't know what we don't know. So it's asking a fish, what does wet feel like? How do we, how do we mentally think of or envision every 18 months not doubling the number of transistors on an integrated circuit? And we can't.
Right.
We can't even envision that at this point.
I mean, even think back to like your personal computer, right?
Yeah.
Like there was a time in the 90s primarily, right? You would buy a computer and the joke was it would be obsolete before you even took it out of the box, right? Right? Because, the Pentium 90, Pentium 90, and then 2 weeks later the Pentium 120 or 133 hertz came out, right?
Right.
If you're younger, think about the phones. Right?
Yeah. Yeah.
There was a time when every time a new phone come out, you wanted it because it needed to do this. But my phone is, I think I have the Samsung 8, right? So that's not hardly cutting edge, and I'm okay with that because
Right.
I don't really feel like dropping $1,000 in a new phone, even at the rate I crack the screens. It's just not practical for me. But
Same
also
here.
my desktop PCs, and I still have desktop PCs.
Mhm.
I haven't bought a desktop PC in at least 5 years, and
Mm.
I'm okay with that because I don't really tax the processor. I mean, I do when I do video rendering and stuff like that, but I'm okay
Right.
with letting it rest overnight. I don't feel the compulsion to buy a new computer every 6 to 12 months like I did back in the day,
Yeah.
and there's no need. So we are really spoiled. And this is right now, I think, going to start being an upper speed limit for folks in research, but it's just a matter of time before that kind of reaches us kind of in the consumer space and kind of, well, for data engineers and data scientists, it's going to hit a little sooner than that. So
Yeah.
why is that?
Yeah, we've seen this undulation happening. I
Right.
mean, with the first winter we talked about, arguably the second winter that probably ran from sometime in the 80s to the late 2000 aughts. I'll say
Right.
2000 years. But and here's the thing. If you do an analysis on those time spans, you'll see that they are shrinking, and there's every indication that the next winter that we're coming into won't really begin for a few years,
Right.
and that it will also shrink, and it may take. Here I go, Frank. It may shrink in a quantum leap
Yeah,
fashion.
quantum leap forward.
It might, and
It
that's
might.
where I think that's where we're going. With the show here is how does quantum impact the worlds of machine learning and data science and AI, and we both know that it's a big swap. We also both know because of Q sharp you mentioned earlier
Mhm.
that some of the algorithms that have been developed in this tool that's for all intents and purposes hypothetical. It allows you to code in this language in this for these this hardware that exists. It's not that it doesn't exist today, but it's really rare. There's a handful of quantum computers on the planet as we
Right.
speak. But the advances that they've made, just thinking about how will we code in it, what will Q sharp algorithms look like, how will they perform, and in doing that, we've already made improvements in the performance of these algorithms.
And here's the exciting part. We are still a number of years away from an actual real quantum computer being practical, cost effective, and feasible.
Yeah,
However, if you look at this chart, you can see that, I mean, it's still a number of years away
Mhm.
before this is going to be kind of a thing, right? A thing that you can, the next iPhone is not going to be the iPhone Q, right? I mean, that might be the iPhone 25 or 30 or whatever. But the reality here is, and this is the thing that blew my mind, is the notion of simulating quantum algorithms on conventional hardware.
right, right, and that's what's different about this whole thing. I think.
Right.
I've you and I have both worked with simulators. This isn't anything new.
Right.
We've seen code simulation, but what we haven't seen, I'll say it this way: what I have never seen prior to a language like Q sharp is
Mhm.
being able to simulate responses on a platform that is being created at the time.
Right. And I think it's interesting. It's kind of like emulation, but I think it's a little more than that.
Oh yeah,
It's what's interesting is, so here's kind of the thing, and I recently had a discussion about this. I've so since that kind of that aha moment, I've actually have given 4 customer presentations on Azure Quantum, and I've delivered 2 community presentations on Azure Quantum. Not too bad for a technology that kind of doesn't exist. I mean, Azure
right.
Quantum is very real. IBM has an offering. Amazon just announced something. Google's working on it. D-Wave is a separate company. There's another company that was very quiet, and then they all privately funded, and I think they might have figured something out the way they're acting in terms of filing for IPOs and stuff like that. So a lot of interesting things in this field are happening right now, but you don't have to wait, because here's the thing: simulating quantum computing on standard hardware or even specialized hardware that exists out of regular silicon is here. It's today. There's a YouTube video that's as Fujitsu has a kind of like a GPU, right? I know a lot of people are going to write me and be like, "That's not really."
Yeah.
But in the sense that you can offload some work from the CPU onto GPU, like you could with, dare I say, WPF applications, or any other thing like that, or neural network training. You could theoretically do that. Now, these machines are not cheap now, but here's the rub. Here's the real business value. This is the thing you want to pay attention to.
Right.
There are a number of, and that's why this fancy slide up, but there's a number of problems that can't be solved with conventional compute. It would take the age of the universe or a very long time to solve these problems of conventional compute with conventional algorithms. Quantum computing, a real quantum computer, would be able to do it significantly faster. We're talking things like, does P equal NP type problems, like the really kind of traveling salesperson thing, like that sort of stuff, is very difficult for classical computing to accomplish. With quantum, it will take, seconds or minutes, right? Hours, right? Kind of what we're used to now with regular compute. But these are much bigger problems. Problem is, we are some years away from that being affordable and realistic, right? Yep. Now, here's the cool thing. Here's the thing that is not immediately obvious. What if you were to simulate a quantum computer on conventional hardware? You don't get the answer in seconds, but you don't get the answers in hundreds of thousands of years either.
Right.
It could take 10 months, could take 6 months, could take a year. But the idea is that it's possible in not only in our lifetimes, but in a way that it could actually produce business impact.
Yep.
That's explosive.
It is.
In my mind.
I think it's very easy to look at that and just, and be blasé. Be blasé in that kind of response. It's like, what? You're telling me this problem is going to take weeks or months to solve? And it's like, but you don't understand.
Right.
The recursion.
If you asked me a few months ago, I would have said this would have taken 10,000 years.
Right. And just people don't, it's going back to your original class experience, Frank. The guy was talking serious, AI, recursion. That's a huge part of this. You keep recursing and getting the answer and storing it. You get to recurse again and get that answer and store it. And then you can calculate your probabilities. And, that takes forever if you're doing, this process. And even with parallel computing, it takes forever.
Right. Well, parallel computing, I think, is kind of bridges the gap where we don't notice that Moore's law is not as spry and young as it used to be.
It does help. Yes,
it does help. We can kind of ignore that. It's the stuff you rub on your joints when they're sore, like it, or the Advil that you take to make those aches go away. Like you can forget that there's underlying problems.
Right.
But I mean, that's really the key here, and I think you hit the nail on the head when you open up Q Sharp, and there's more than just Q Sharp now as quantum language. There's Circ. There's another language. There's extensions to Python. I forget what it's called, but basically you can write quantum code in Python. And ultimately, it's going to enable all sorts of new algorithms because you're adding that extra logic gate. That, because you have this third state. So if you think about the old school ways of logic gates, and this is stuff that realistically, I haven't seen this since I was taking comp sci in university, right? I mean, this is probably not taught in a lot of, the logic tables are probably taught in these learn to code boot camps and such, but the actual how that happens and is manifested in electrons and
Right.
circuits is probably not. Because again, we have the luxury of being completely oblivious to this sort of thing.
See, I built these circuits, Frank. I mean, we were
Right,
on
right.
a breadboard putting transistors together.
There's a reason why you're here, man.
Back in the day, we used to carve our own chips out of wood.
Out of wood. Yeah.
Kidding. But we did.
So I mean,
build these
I would say what's fascinating about this is that if you look at this, you know, this is going to change how things are done at this level of detail. Because ultimately, with conventional circuits, you are dealing with the power of electrons, right? Electron flow is flow, right? It's binary, right? On, off, zero, 1, 0.
Right.
With quantum, you're taking advantage of some of the effects of quantum physics here, and this is what makes it hard. This is what also makes it exciting, is that you add the ability of uncertainty, right? Is the state going to be represented as 1 or 0, or could it be both, right? And
Right.
in future shows, we'll kind of explain how does 1 plus 0 equal something other than 1, right? We will explain that, but here's a hint if you're impatient. You're not adding integers, you're adding vectors.
Right.
I explained that to a guy I work with who has a long history in designing circuits and servers and stuff like that. And I could see like that was the explanation that got to him. He was like, aha. And for me, that's how I had my aha moment too.
Yep.
But because you're changing these logic gates, you have entirely new operators and stuff. So there's a Hadamard gate, right? I saw the first Q sharp code I saw was basically it was dealing with all these different operations and stuff, and I'm like, that doesn't make any sense. So as a software engineer, or anyone who wants to write these algorithms, you're going to have to kind of relearn kind of the core fundamental stuff. And that's a good time to plant the trees, 10 years ago.
Absolutely. And I'll just throw into this that I love matrix math. I always have. I've just been drawn to it since way before I had, we're talking, I don't know, Frank, 45 years ago or something, before I had any use for it at all. But
Right.
I'm kind of I'm not super smart when it comes to math, but I'm definitely attracted to some of these things. So, vectors and set math, I was always kind of attracted to that matrix math. And it's a great time, I think, to do to point out that Frank's got a throwback to matrix math behind him.
That's why I have it on. If you're watching the video, I have a 6 monitor setup. It's where I do all my video editing and stuff like that. I have the matrix screensaver because it looks like I'm in the bridge of the Nebuchadnezzar, as I've been told. But I mean, that's really the key, is that this is the time to learn. Are you going to be writing quantum, production Q-sharp code tomorrow? Probably not. Next week? Also probably not. But this is going to be a thing. And I predict that, in 5 years' time, you're going to have recruiters saying, hey, do you have 10 years experience in Q-sharp?
That's funny.
So even though the language is maybe 2 years old, you could have 5 years experience in 5 years of Q-sharp.
True.
Maybe not the 10 or the 20, but I see a similar curve. I see a pattern recurring. And that's what data scientists do. We find patterns. And
Very true.
so in future episodes, we'll be getting more into kind of, what does it mean to have multiple states at once? Like, what does superposition mean? What can that do? In the meantime, I am continually learning and reading. I have this book here, Quantum Computing in Applied Approach. I've written a couple of things based on my understanding, and on LinkedIn articles. I'm going to blog a lot about this. I'm going to tweet a lot about this. But, the best way to get information out, I think Andy and I have seen, is through a podcast.
Yeah.
Now, we are lucky to start this podcast also as a video feed, too. So there'll be sometimes you just have to watch the video. I try my best to explain things, and if you're listening to this only on the podcast feed, but there are going to be some concepts that are going to be hard to get your head around. We'll do screenshots and put them in notes or something. We are experimenting. And the idea for this show only came about on July 31st of this year. So if you're familiar with the data-driven, it took us about, what would you say, Andy, about 4 or 5 months?
Easy. Yeah,
to
it was
get
much
the first
before
show from ideation to execution. This time I'm
Yep.
doing it in just under 2 weeks.
It's
Or
because
3
you rock, Frank.
Thank you. This is not the first rodeo, so it definitely helps to go a lot faster.
True.
So with that, one of the problems we know we're going to have with the show is Andy's designed electronic circuits. I know my way around these logic gates, but I'm not a quantum physicist. I never even played one on TV.
Same
I can't
here.
go anywhere in a quarantine, so I can't even stay in a Holiday Inn Express, Andy. It's that bad. So we're going to need help. So if you have experience with quantum physics and you can help us explain these topics, our audience is primarily software engineers, developers,
Data people.
data people. Of course, I love my data people. I'm a data people now.
You are.
So it's definitely gonna need to help. If anyone with experience in matrix math or linear algebra will help. True story, actually. The second time I presented this to a customer, Azure Quantum to a customer, somebody in the audience was also fascinated with quantum computing, and he actually has a degree in econometrics, which essentially is linear algebra applied to economics.
Nice.
So I told him, I was like, I mean, this could be your next career if you wanted it to be, because you have the math already, and you can code. I mean, if you think back to the Venn diagram of the 3 circles of what made a data scientist in the early 2010s, they code, they had the math, and they had the subject matter expertise. He already has 2 in this field,
Right.
and he is a subject matter expert on some things. But I'm just saying, anyone who kind of knows linear algebra or matrix math, depending on what you want to call it, has a significant bump in this. And this is going to do for folks who know that level of mathematics and quantum physics, particle physics. It's going to do for them what data science and AI did for statisticians. Suddenly they were rock stars. I think you're going to see that here.
Totally agree. It's going to be fun, and it's definitely exciting and new. As some of our listeners are pointing out here while we're live on LinkedIn Live.
Yes.
Yeah, they're excited about it as well. You and I have lived through a number of these, Frank. And I don't know what the right term is for them, but they're definitely these points and these peaks.
Inflection
technology.
point? Is that the word you're looking for?
Yes, inflection points and just technology in general. And I see them about once a decade. I'm just kind of throwing that out there, and it's always something new, right? It's never. For me, I wasn't at least I wasn't deep enough into technology in the 80s to see the AI bump that happened there. But I was around for the web, and business web, and I was around for microservices and the cloud. And this, I think, is the next big thing. I think quantum is going to impact everything, and because it's definitely infrastructure, right? We're talking about hardware. And because the coding principles are there as well, it touches both hardware and software. And I can't remember this happening on at this level, at this scale, at the same time. I think this is going to be the biggest one in my 45 years of a hobbyist computer person and then professional.
Yeah, and everything we know about computing has the assumption that it's binary. It's everything we've run.
Right.
Whether you're doing your math homework, talking to Siri or Cortana or Alexa, whether you're arguing with strangers on the internet, it's all digital, right? It's all that digital state, and it's always been on electrons, right? It's called electronics.
Exactly.
It's we have really taken, I love history, so if you kind of take this back further, right? Society, as we know it, was founded after the agricultural revolution, where we could have a stable supply of food and could stay in one place, right? You don't build cities if you have to forage in the forest or across the plains every couple days, right? You just don't.
Exactly.
And so our first thing we kind of harnessed was the power of the seed. Then during the Industrial Revolution, we harnessed originally the power of steam and the power of kind of burning fossil fuels, if you will.
Right.
Or the power of fossil fuels or hydrocarbons. Then we got into the ability of harnessing the electron, right? In the middle of last century, we got into the atomic age, right, where we were harnessing the power of atoms. I think the 21st century is largely going to be defined by how do we harness quantum particles.
Yeah.
I think that's kind of the next wave. And there's not a lot of other podcasts about quantum computing right now. I think that's going to change.
Yeah.
It's part of the reason I wanted to execute in 2 weeks rather than 5 months. But if you do a search now you get some interesting results if you just do a search on a podcast directory on quantum, right? It tends to be
Absolutely.
more metaphysical than about kind of quantum computing, certainly, or science of quantum mechanics.
But there's a few. There's a few.
There's a few. I'm not saying we're the first,
Right. Yeah. We're definitely.
But I'm just saying, that's kind of where the point I'm trying to make is that whenever a new technology or class of technology comes out, there's always a lot of science fiction and kind of hype around that technology. And that's good because that inspires the next generation of engineers, right?
Totally.
But, if you think about the first, arguably the first science fiction series was about Frankenstein. And that was Mary Shelley. Electricity was the magic factor that made the dead come to life, right?
Right.
You see throughout history, if you look at old sci-fi films in the 50s, right, it was atomic this, atomic that, right? So you're going to start, I think, as this kind of starts disseminating throughout the world, you're going to see quantum kind of pop up in these science fiction things.
Yeah, absolutely. We have a couple questions, Frank, if I can.
I do.
So one is, and I think you've been answering this one throughout the show, is how is the butterfly effect an exception in quantum mechanics?
So I'm not qualified enough yet to answer that question. The butterfly effect is, I thought, a proving of mechanics. I didn't think it was an exception. It was the idea that a butterfly can flap its wings in Singapore and cause a tornado in Kansas or something like that.
Yeah, and I totally agree with you on that. I think it's early. I think it's early to even answer that question or
right.
That answer. But it's
you are a physicist or one. We're happy to have him on the show. We'll record on audio or video. We just wanted to do a video for this one. I see the other question is from Yasmin. Mm-hmm. Is this a series? Yes, it is. It is a new podcast. We are streaming this live to do the recording because we want to be innovative, but also it actually makes production faster, believe it or not. Once you go through the trouble of doing it by video, the post-production to turn this into a podcast is a lot easier than you would think.
Well,
so yes,
it's easy.
This is series.
It was easier for us earlier than some because Frank built a suite of awesome tools.
Thank you.
That he's had up in it was in Azure VMs, I think, to start with. I don't know if it's still there or not.
It's an Azure web service now.
Yeah, like 3 years. We've had. I say we. Frank's had this, and he'll just drop the video in there, and it separates out the audio for us. And I think it was actually sending it over to the site and getting everything ready at datadriven.tv. Yep. Recently, you added automation around transcribing.
Yes. Well, that's still semi-automatic, but yeah.
Semi-automatic? Okay.
Yeah.
But we've had, Frank would just drop a URL in the bucket. It's kind of where we went to, a URL into the text box and push the button. And a few minutes later, we'd have audio sitting over at datadriven.tv. Magic.
Yeah, it's pretty
Magic,
cool.
Frank.
Yeah, I'm proud of my tools, and they're speaking of Frankenstein, they are like this Frankenstein mix of kind of like off the shelf services and stuff I built. Mm-hmm. So
I call that automation.
Yeah, so,
I call that
RPA,
automation.
man. It's the new
Yeah.
hotness for robotic process automation.
There we go.
So I think we've kind of covered everything that I think is reasonable in terms of the first episode. We are going to have more of these episodes. We are going to be kind of limited in the sense of having guests because there's not a lot of quantum computing experts in the world right now.
That
But that's
can
also
talk.
the opportunity. That's also the opportunity. It gives us a chance to grow. It gives us a chance to kind of take the input here and kind of digest it and expose it to really kind of a trailblazer in that thing. And that's it's not going to be easy, but it's going to be fun.
Totally agree, Frank. I'm glad to be along for the ride.
Wouldn't have it any other way, dude.
Hey, brother. Yeah, man. So I appreciate folks that tuned in here on live and asked great questions. I love this about streaming that we can interact with the audience as we go. Yes, absolutely, Yasmin. As Frank said, this is going to be a series. We're kind of debating. It may actually turn into its own podcast. We'll see. We'll see if we can get enough guests.
Right. A lot of that's going to depend on how much is it going to cost to get another hosting.
Well, it could still be technically another.
Well, what I can do without it at additional cost was is have another RSS feed and have a website, have a web page that'll live off the data-driven thing. So this is going to be kind of a spin-off series, like what Space Nine was to the Next Generation.
There we go. Which that worked out really well.
Yeah. So far, so good. We have the cool sounding dubstep intro music and stuff like that.
Love it.
We now have the AI ability to use an AI to generate the custom lead-ins and stuff like that. And we are always looking for sponsors because we have bigger and grander plans. So our mission is to help people grasp these different problems that, when I first got into data science, there was definitely like this clash of kind of the people who had been in academia, assuming that in order to do data science, you had to be one of those researchers, right? There was a clash, and I think we're going to see the same thing here, right?
Yeah.
Most people were not interested in business about quantum computing up until maybe 5 or 6 companies a few years ago. But you're going to see this kind of explode. So you're going to see a lot of these folks who traditionally been in academia kind of thrown into roles of business, in kind of the business world, and they're going to have to deal with practitioners, as they called me in the early days.
Yeah.
One gentleman in a tweed suit, and this was July too in DC. So if you're wearing tweed in July in DC, I mean, you committed. You're like the Mandalorian. Like, this is the way. Like, you don't take off that tweed even in the heat. He was sipping tea in a very posh kind of British thing. I'm so glad we now have practitioners like you at these events. And I was like,
yeah.
I can't tell if I was being insulted just now.
Yeah. Well, I'll tell you, I remember going through that. You and I both going through it. You more than me, because I never made a claim to data science. I always stuck with, data engineering, and I'm comfortable there. I'm glad for folks like you and the data scientists that we've interviewed on the show, and analytics practitioners, business analysis pros. But one of the things that happened is there were 2 or 3 guests early on the show, data-driven show, that you posed that question to, and no one could question their credentials as data scientists.
That's right. And they did not have PhDs.
They all, I think one of them did.
And we did have some PhDs in there, yeah.
Yeah, but even then, they all responded the same way, no. And
right.
I think we were, we talk a little bit about how we started data-driven as a little reactive in that. I'm not so sure. I think we caught it in the middle of its transition, at least.
We totally did. And I would like to imagine that we had a little bit of help in that transition. So we were one of the little ants pushing around the big leaf that fell off from the sky. I don't know, whatever the thing is. But I think we were definitely part of the zeitgeist, if you will. And I think that there's going to be another shift, and I want to be more. I want to pay it back. Like, we had recorded another show where we were announcing this show, on data driven, and I want the opportunity to pay it back because it was paid forward to me. Like, people said you don't need a PhD to do this. You can, reshift your career towards this. And I'm telling you the same thing.
Yeah.
Now, the only thing at this point is I know quantum computing is going to be a big shift for this industry. What I can't tell you is it going to be in 5 years or 10 years. I don't know. And I don't know who the winning team is. So full disclosure, if you see behind me watching this, that's my old license plate when I lived in Virginia, right? Tablet. Because I was a tablet PC MVP. So I was doing handwriting recognition and working on mobile kind of tablet devices 5 to 6 years before the iPad came out.
Yeah.
Right? So I can kind of sometimes get a glimpse of what's next. I don't always necessarily pick the right way it's going to manifest itself. So,
yeah,
or how long it'll take. I swore up and down that 2007 would be the year that, tablets would take off. It wasn't. Yeah. But you know what? It did take off. I could be off on this time. When it came to the web, I was about on schedule with that one.
Yeah.
So, but again, so little bit of, take that with a grain of salt. Is this going to happen? Yes. Is it going to happen in 3 years?
Totally.
I don't know. 5 years? I don't know. But I do think that if you look at the amount of money that's being thrown at this from Microsoft, from Google, from AWS, from D-Wave, and all these other firms that are doing this, IBM as well, this is going to happen. Don't know when, but it's going to happen.
And we also know, too, just by the nature of these things, that it's going to start small. It's small now.
Right.
And it's going to grow from here, and at some point, it's going to hit one of those inflection points that I was searching for that word earlier.
Absolutely.
And it's probably going to hit several in its, as we go. And although Frank and I can't predict when it will happen, we're both in total agreement that it will.
Well, again, I mean, more than just these MIT researchers have started sounding the alarm that we are hitting in a computational limit. And then that is going to be the next opportunity, is solving that.
Sure.
So cool. So thanks for everyone who are watching us live. If you're watching the recording, thank you. Thank you for the comments. And thank you, Andy, for catching all those. We have a domain name. It's impactquantum.com, the impact of quantum. And we are doing a kind of what we did with Data Driven, doing a soft launch today. And then once we get into the iTunes store, it'll be officially launched. But we're good.
Awesome.
All right. Thank you very much. And you have a great day. Done. We're finished.